Okay, so here we will discuss half subtractor. What is half subtractor? Half subtractor is nothing but a combinational circuit. Suppose this one is the combinational circuit. So half subtractor is a combinational circuit. What is its work? Its work is to subtract two inputs. Its work is to subtract two input. Suppose I am considering two input as A and B. So this circuit, this half subtractor, I am writing this half subtractor as H of S. So this half subtractor circuit is used to subtract these two bits only. Okay, and accordingly it will provide two outputs. One output is represented as difference D, and another output is represented as borrow B. Here these input is also represented as B. That's why we represent this borrow output as B naught. Okay, so what is the definition of half subtractor? Half subtractor is a circuit that is used for the subtraction of two bits, and after the subtraction it will provide two outputs. One is represented as D, that is difference, and another output is B naught, that is borrow. The whole characteristic of half subtractor can be understood by using a table. This table is known as truth table. Okay, so I am making a truth table for half subtractor. Here this one is the truth table. Here I am writing one input as A, another input as B, output as D, and the second output is B naught. Okay, so because of two inputs, how many inputs are there? These are A and B are the inputs, and what are the outputs? This D and B naught are the outputs. So because of the two inputs, four different combinations are possible: 0 0, 0 1, 1 0, and 1 1. Okay, now I am subtracting first combination 0 and 0. So when we subtract 0 minus 0, so what we will get? 0 minus 0 equals to difference is 0. Is it in this case borrow is required or not? No, no borrow is required. That's why we have written B naught equals to 0. Now I am considering second case. That one is 0 minus 1. So in second case our input is 0 and 1. Is it possible to subtract 1 with 0? No, it is not possible without taking the borrow. So that's why we required a borrow. So when borrow is required, so we have written 1 here. Okay, so when borrow is coming, so this 0 will be 1 0, and 1 0, when 1 is subtracted with 1 0, then the difference will be 1. So I have written 1 here. Okay, now we consider third case. In third case, input is 1 and the second one is 0. Is it clear? So when 1 is 0, so at that time we will find output as difference as 1. So I have written difference as 1. Is borrow is required in this case? No, no borrow is required. That's why I have written B0 equals to 0. Now I am considering this last case. In last case 1 minus 1 is there. 1 minus 1, so difference equals to 0. Difference equals to 0. Is borrow is required? No, no borrow is required. That's why I have written B naught equals to 0. Okay, now by using this truth table we can calculate the equation. Now to calculate the equation of D, I have written here D. Okay, we will check the one in difference column and its successive input combination. Its successive input combination is A equals to 0 and B equals to 1. So in the terms of A and B, I can write 0 as A bar and B 1 as B. So I can write it as A bar B. Is it clear? Now the one more one is there. So what is the input combination in terms of A and B? We can write here A B bar. So A bar B plus A B bar is nothing but a XOR B. Is it clear to all of you? So this one is the difference equation. This one is the difference equation. Okay. Now this one is the difference equation. This one is the difference equation. Now we will calculate the equation for borrow. I have written B naught. So to calculate the equation for borrow, we will check the borrow column. In borrow column only this one is there. So I am writing the input combination with respect to this one. So it will be A bar B. So I have written A bar B. Okay. So this one is the borrow. This one is the difference and this one is the borrow. Is it clear to all of you? By using this difference and borrow equation, we will represent logical representation, logical representation. What is logical representation? Anything that is represented by using logic gate is known as logical representation. First, I will choose the direct equation. The equation for difference is A XOR B. So I am taking one XOR gate. This one is the XOR gate. Okay. Here one input is A and another input is B. That's why we will get output as D. Now, second one is borrow B not equals to A bar B. To find out A bar, we need a NOT gate. So here we will find out A bar. How can we find out B? We fuse the path here and then connect one AND gate here. Okay, so from this path we will get B naught. This one is the logical representation, first type of logical representation. Is it clear to all of you? Now, can we represent this equation by using AND OR logic? Can we represent the above equation by using AND or NOT logic? Now, what is AND or NOT logic? If we draw the logical representation of any circuit by using AND or and NOT gate only, so it will called as AND or NOT logic. Okay, so we know that difference equation is A bar B plus AB bar, and the borrow equation B naught will be A bar B. So I will try to represent this equation by using AND or NOT logic only, AND or NOT gate only. Is it clear to all of you? Okay. So here I am taking one NOT gate. If the input is A, so here we will get output as A bar. Here I am taking input B and I will connect these two inputs with the AND gate. So what we will get? We will get A bar here. This one. Okay. Now we need AB bar. To find out AB bar, we just connect one NOT gate here and we will fuse path and take A from this path. Now I will draw one more AND gate and from this path we will get AB bar. Now these two inputs are connected with plus. Plus means OR gate. So I am connecting one OR gate here. So from this path we will get the difference equation. Okay, now the borrow equation equals to A bar B. So if this one is the A bar B, so from this path we can directly find out B naught, that is borrow. Okay, fine. So this one is the second logical representation by using AND or NOT logic. Now if I want to draw half subtractor circuit by using NAND gate only, if I want to draw the circuit by using NAND gate only, so we know that uh, we know that we know that and we know that half subtractor circuit is represented by using one XOR gate one NOT gate and by using one AND gate only. Okay, we already seen this. We already seen this in our previous case. This one we already seen in this type of representation in our previous case. Okay, so here represent I am trying to represent this XOR gate, this NOT gate, and this NAND gate, this AND gate by using NAND gate. So we can draw XOR gate. We can draw XOR gate by using NAND gate as this one, this one, this one, and this one. So by using four NAND gate, we can draw XOR gate. Okay, so this one is the output of XOR gate. Okay, so if A is there, B is there, so accordingly we will get a difference from this path, because this XOR can be represented by using NAND gate by using this combination only. Okay, is it clear to all of you? Now we need one NOT gate. We need to implement one NOT gate to convert A into A bar. To convert A into A bar, we just need one NOT gate. So what I will do, I am connecting. So what I will do, what I will do, I will connect A, and then by connecting both inputs, we can find out A bar. Okay, now now how can we implement, now where, from which end we can find out B? I am taking this input and increase it here. This one is B. Okay, A bar B. Now I want to implement AND gate by using NAND gate. So we already know that if we connect NAND gate serially, then this combination will act as a AND gate. So this one is the representation of half subtractor by using NAND gate only. Okay, so this one is all about the half subtractor. Thank you so much.